So good morning all. Let alpha comma beta be the roots of the equation x square plus x plus 1 is equal to 0. Then the equation whose roots are alpha to the power of 19 comma beta to the power of 7 is that we need to find out. So that means, my dear students, you can find out the roots of x square plus x plus 1 is equal to 0 using quadratic formula. So that means you can write like this: the roots of x square plus x plus 1 is equal to 0 are alpha is equal to omega, beta is equal to omega square. Omega and omega square are the cube roots of unity. Cube roots of unity, where you can remember like this also, where omega is equal to minus 1 plus root 3i upon 2. And omega square is equal to minus 1 minus root 3i upon 2. Since omega is the root of this one, if you substitute omega, you get this condition: omega square plus omega plus 1 is equal to 0. So that means sum of the cube roots of unity is 0 and product of the roots omega into omega square, that is omega cube will be 1. Using these facts, so now we can find out the quadratic equation whose roots are alpha to the power of 19 and beta to the power of 19. If you take alpha is equal to omega, this becomes omega to the power of 19, whereas beta is equal to omega square, this becomes omega to the power of 14. So that we need to find out now. So first, sum of the resultant equation or new equation, that is alpha to the power of 19 plus beta to the power of 7. Let us substitute alpha is equal to omega to the power of 19 plus beta is equal to omega square whole to the power of 7, that is omega to the power of 14. So I will tell you one logic. Divide 19 by 3. If you divide 19 by 3, you will be getting remainder is 1, because 3 6 ja 18, 19 minus 18 is 1. This becomes omega. Divide 14 by 3, so you will be getting omega square. Omega plus omega square is equal to negative 1. So that means sum of the roots of the new equation is 1. Let us find out product of the roots. P, product. So product is equal to alpha to the power of 19 into beta to the power of 19. Sorry, beta to the power of 7. Alpha to the power of 19 is omega to the power of 19 into, that is omega to the power of 14. That's nothing but omega into omega square. Omega cube. See, omega cube is equal to 1. Now we know the sum of the roots and product of the roots of the equation. Now the required equation we can find out. The required equation is x square minus sum of the roots into x plus product of the roots is equal to 0. So that implies we get x square minus sum of the roots is equal to negative 1, minus into minus plus x, product of roots is 1, so plus 1 is equal to 0. This is the required equation. That's why fourth option is the right option. So very interesting question this is. So let's move to the next question. The equation formed by decreasing each root of ax square plus bx plus c is equal to 0 by 1 is 2x square plus 8x plus 2 is equal to 0. Then first option, a plus b equals to 0. Second option, b plus c equals to 0. Third option, b is equal to c. Fourth option, a is equal to b. So let us try to solve this problem now. The equation formed by decreasing each root of this ax square plus bx plus c is equal to 0 by 1 is 2x square plus 8x plus 2 is equal to 0. The equation 2x square plus 8x plus 2 is equal to 0 is obtained by having decreased the each root of ax square plus bx plus c is equal to 0 by 1. So that means if you say alpha comma beta are the roots of ax square plus bx plus c is equal to 0, then obviously the roots of 2x square plus 8x plus 2 is equal to 0 becomes alpha minus 1 and beta minus 1. That's all. With the help of that, we need to establish the relation between coefficients of the first equation a, b, c. So let us try to solve this question. So let the roots of ax square plus bx plus c is equal to 0 be alpha and beta. That implies the roots of 2x square plus 8x plus 2 is equal to 0 are alpha minus 1 and beta minus 1. So now, since alpha comma beta are the roots of this equation, we have this relation. Alpha plus beta is equal to minus b upon a. Alpha beta is equal to c upon b. Now, from the second equation, let us find out here alpha minus 1 plus beta minus 1. That is equal to here minus x coefficient, that is minus 8 upon 2. So we get like this, alpha plus beta minus 2 equals to, we have minus 4. So alpha plus beta is equal to minus b by a. So minus b by a is equal to, you have minus 2, because minus 4 plus 2, you have b is equal to 2a. This is one relation. Say equation 1. Next, product of the roots find out. Alpha minus 1 into beta minus 1. Alpha minus 1 into beta minus 1 is equal to, from this equation 1 we have. This is alpha beta, right? Minus alpha minus beta plus 1 equals to 1. So alpha beta is equal to, you have 1 minus 1 is 0, alpha plus beta. So now alpha beta is equal to c upon a. Alpha beta is equal to minus b upon a. A gets cancelled, bring minus b this side. Therefore, you get b plus c is equal to 0. You check whether b plus c is equal to 0 is there in the options. Yes, second option is the right option. Second option is the right option. Question number 20.
That's your previous picture, not sure. Okay, sir.
If alpha beta are the roots of x square plus 2x minus 1 equals to 0. Then the equation whose roots are whose roots are 1 by alpha comma 1 by beta is first option 2x square plus 3x plus 18 is equal to 1 minute. So I did the question wrong. Sorry, if alpha comma beta are the roots of x square plus 2x minus 1 is equal to 0, then the equation whose roots are alpha square comma beta square is first option x square minus 6x plus 1 equals to 0. Second, x square plus 6x minus 1 equals to 0. Third, x square plus 6x plus 1 equals to 0. Fourth option is x square plus 6x minus 2 equals to 0. So if
Option 1.
very good. If alpha comma beta are the roots of x square plus 2x minus 1 is equal to 0, then the equation whose roots are alpha square comma beta square we need to find out. Very simple. If alpha beta are the roots of the given equation, if you want to find out the equation whose roots are alpha square and beta square, simply put x for root x and get simplified, you'll get the required equation. So here now solution, what is the solution means? Put x for in the place of x root x. So in this equation, so that implies you get like this, root x whole square plus 2 times of root x minus 1 equals to 0. Here we get like this, 2 root x equals to, this will be root x whole square is x, negative 1 minus x, squaring on both sides, because we need quadratic equation, squaring on both sides, this will be 4x square. So that equals to, right, what do you get now here? 2 root x is equal to, right, 1 minus x only. 4x is, sorry, this is 4x.
4x.
Yeah, 4x. Right. Mm. 2 root x is equal to 1 minus x. This is 4x equals to 1 minus x whole square means a minus b whole square, 1 plus x square minus 2x. So therefore take minus 4x that side, x square minus 6x plus 1 equals to 0. This is the required equation. So x square minus 6x plus 1 is equal to 0. Very good. First option is the right option. Now the 21st question. If alpha comma beta are the roots if alpha comma beta are the roots of x square plus 6x plus 9 equals to 0, then the equation whose roots are 1 by alpha comma 1 by beta is first option 2x square plus 3x plus 18 equals to 0. Second option x square plus 6x minus 9 equals to 0. Third option 9x square plus 6x plus 1 equals to 0. Fourth option is 9x square minus 6x plus 1 equals to 0. Alpha comma beta are the roots of x square plus 6x plus 9 is equal to 0. Then the equation whose roots are 1 by alpha comma 1 by beta. So
Option 3.
very simple.
Option 3, sir.
Yes. So now put in the place of x 1 by x in given equation. This is the given equation.
Alpha is y minus 1 by 6 and beta is 1 by 8.
Okay. So that implies what you get now here 1 by x square plus 6 upon x plus 9 equals to 0. So multiply both sides with x square. You get 1 plus 6x plus 9x square is equal to 0. It can be rewritten arranging the terms 9x square plus 6x plus 1 equals to 0. This is the required equation. That means option 3 is the right option. So otherwise x square plus 6x plus 9 is equal to 0 is x plus 3 whole square is equal to 0. The roots are x is equal to minus 3 and minus 3. Roots are actually we need 1 by alpha, 1 by beta, minus 1 by 3, minus 1 by 3 are the roots. Sum find out that will be minus 2 by 3. Product will be 1 by 9. So x square minus sx plus p is equal to 0. You can solve it, no problem. Any method you can solve. But this is my suggested method. Any method you can do. So you should not actually restrict to one method. So whatever method you have the idea, you can explore yourself. 22nd question. 22nd question. So before that, let me revise once again today's questions. This is 21st question. This is 20th question. This is 19th. This is 18th question. So this is for the benefit of late viewers. Take the screenshots. Right. 22 question. The equation whose roots are k times the roots of the equation equation. Ax square plus bx plus c is equal to 0 is first option ax square plus kbx plus kc equals to 0. Second one, ax square plus k square bx plus kc equals to 0. Third option, ax square plus kbx plus k square c equal to 0. Fourth option, ax square plus k square bx plus kc. So 1 minute, this is minus kc equals to 0. The equation whose roots are k times the roots of ax square plus bx plus c is equal to 0. Suppose the roots of ax square plus bx plus c is equal to 0 are alpha comma beta. Find the equation whose roots are k alpha comma k beta. That we need to find out. So that means first of all, since alpha comma beta are the roots of this equation, we have alpha plus beta is equal to minus b upon a. Alpha beta is equal to c upon a. So now sum of the root sum, that is k alpha comma k beta, that we need to find out, because k times the roots of this one, k alpha k beta. So k common, alpha plus beta, we get minus kb upon a. Next product, k alpha into k beta, that is k times of alpha beta, that we have k square c upon a. Now required equation. See, required equation is x square minus sum of the roots into x plus product of the roots is equal to 0. That implies now resulting equation or new equation is x square minus of minus kb by a. So that will be plus kbx by a plus p. P stands for here k square c upon a equal to 0. Multiply with a. We get ax square plus kbx plus k square c equals to 0. So which is the right option?
Option 3.
Option 3 is the right option. But instead of doing like this, but we have very beautiful shortcut. So given equation is this one, ax square plus bx plus c is equal to 0. For example, if you want to find out the equation whose roots are k times the roots than that of ax square plus bx plus c is equal to 0, simply multiply first term with k power 0, second term with k power 1, third term with k square. See what do you get? K power 0 is 1, 1 into ax square, k power 1 is k, that is kbx,
KBX
k square c
plus
equal
K
to.
square.
Without paper pen you can solve this problem. But this is the concept behind this question. And moreover, one more thing also. If ax square plus kbx plus k square c is equal to 0, means alpha comma beta are the roots of ax square plus bx plus c is equal to 0. And whereas the roots of ax square plus kbx plus k square c are alpha k and beta k. Alpha k and beta k. 23. If alpha comma beta are the roots of the equation ax square plus bx plus c is equal to 0, then the roots of the equation ax square plus b lambda x plus c lambda square equals to 0, provided lambda does not equal to 0, non-zero real number, or so first option lambda alpha comma lambda beta, second option is alpha by lambda comma beta by lambda, third option alpha comma beta, fourth option alpha to the power of lambda comma beta to the power of lambda.
Option 1.
Yes, I already told you. So if alpha comma beta are the roots of this equation, obviously the roots of ax square plus b lambda x plus c lambda square is equal to 0 or nothing but alpha lambda beta lambda. First option is the right option. Okay, let us move to the otherwise you can check the options also. So how to check the options means, you see, since alpha comma beta are the roots of this equation, we know that alpha plus beta is equal to minus b upon a, whereas alpha beta is equal to c upon a. Verification starts. First option. So now you check sum of the roots. Lambda alpha, lambda beta. Lambda common, lambda into alpha plus beta. That is equal to lambda b minus lambda b upon a. You check. So what is the sum of the roots of this one? Minus lambda b by a. Yes, this satisfies. You check product. Lambda alpha into lambda beta. Lambda square alpha beta. Alpha beta is c by a. Lambda square c upon a. C lambda square c upon a. So that's why these two are the roots of this equation. So now the 24th question. 24th question. If
That's your previous page, sir. Okay, sir.
if alpha comma beta are the roots of x square plus 2x plus 5 equals to 0, then the equation whose roots are alpha plus 1 upon alpha comma beta plus 1 upon beta is First option 5x square minus 9x plus 4 equals to 0. Second, 5x square minus 8x plus 4 equals to 0. Third one, 5x square minus 10x plus 4 equals to 0. Fourth option, 5x square plus 9x plus 4 equals to 0. Here alpha comma beta are the roots of x square. This is equal to alpha beta plus beta plus 1 upon alpha beta. See again, alpha beta is minus 2 plus 5, or 3 plus 1, 4, 4 by 5. Now you can find out very easily. Required equation is x square minus sx plus p equals to 0. That implies x square sum is 8 by 5 minus 8 by 5 times x plus product of the new roots, that is 4 by 5. Now what shall we do? Multiply both sides with 5 so that we get 5x square minus 8x plus 4 equals to 0. Yes, answer is there.
Option 2.
Yes, option 2. Twenty-fifth question. If R is the so unmute yourself.
Okay.
If R is the small r is the ratio of the roots of ax square plus bx plus c equals to 0, then r plus 1 whole square upon r equals to first option b upon ac, second one is 2b upon a, third option is b square upon ac, fourth one is 2b by c. This is also very important problem. If r is the ratio of the roots of ax square plus bx plus c is equal to 0. Suppose alpha comma beta are the roots of ax square plus bx plus c is equal to 0. Alpha is to beta is equal to r is to 1, small r is to 1. Then what is the condition? Condition means if the condition satisfies alpha plus 1 whole square by r is equal to how much, that we need to find out. For this one I will give special note for this problem. If the roots of ax square plus bx plus c equals to 0 are in the ratio m is to n, then condition is, you remember like this, mn b square equals to m plus n whole square into ac. This is important condition, you remember. Here what is given? Here m is to n ratio is equal to r is to 1. Because R is a real natural number, whatever it may be, that can be put R by 1 form. That is R is to 1. That means M stands for R, N stands for K. Substitute here. So therefore you get like this now. R into 1 R, RB square equals to R plus 1 whole square into AC. You rearrange the terms. R plus 1 whole square upon R equals to, you can have B square upon AC. This is the answer. That means third option is the right option. R is the ratio, or sometimes the same question may be given like this. The roots of ax is 1 root of ax square plus bx plus c is equal to 0 is R times the other. That is also ratio equal to R only, R is to 1 only. 26th question. If one root of x square plus kx plus 27 equals to 0, maybe triple the other. Triple means 3 times. 3 times means ratio is 3:1. Triple the other. Then k equals to. First option is plus or minus 6. Second option plus or minus 8.